Hello, good afternoon. And yeah, we're on Friday. Good afternoon, Friday. Hello, Twisted Seed. How are you doing today? How's your week been? So after the end of the stream yesterday, I played. I tweaked around a little bit. I just couldn't help myself after I went and rescued Zilby from his horrible condition of wanting me to accompany him upstairs to use the litter box. That was why in yesterday he required me to emergency end the stream. Right, not too bad. You have a few things planned this weekend, so looking forward to start out. Nice. It's always good to sort of like be able to work on our stuff, actually move forward on projects and all that stuff. Have you not seen this, Twisted Seed? So this is CodinGame. This is a website which allows you to solve coding problems, but usually in game format. So they have the sort of like the normal challenges, like the leak codes type stuff, the code kata style things, but also they have the game version too. So in this case, you can choose whatever languages you want. So we're on Rust. You could choose all of these different ones though. So here's the challenge. It's a multiplayer, so we're playing against other humans when I test in the arena. And actually we can look like what I had in the starting soon screen. That is actually the live battles that my bot, the last time I sent it to the arena, was doing. This is what that looks like. We are right now ranked. Where's mine? Right here. 42,465 in the Bronze League. And then there's the Metal Leagues and then Legendary League. And then I think that's it. So to basically graduate out, we have to fight our way all the way up to rank 1, or at least these top positions, and then beat the boss. And then if we beat the boss, we'll be promoted to the next league. So that's what we're trying to do. Now, we can look at the boss here, sort of like see what the boss is, like where the boss is compared to us, and play locally against them. So that's what we just did here. We won this one, which is good. But I believe that there's some of these that we're not doing so good with. Okay, so tweaks that I did. I tweaked the... Oh, that's not great. I think I missed the first checkpoint there. I'm the orange one in this case. In the real matches, they change up our colors every once in a while, so you have to sort of follow along. I made it so that here, let's go through this race, and then we'll see how that does, and then I'll go through the code changes. All right, a handy win there. Okay, so here's what I changed. First, I added let's see, was it turn early angle? I added a different one of these. So I tweaked these a little bit. So like my turn early modifier is now 3 instead of 5 or 6 that we were playing with. So I really reduced that down. I made sure that our turn early angle is like 1 because I was hitting a bunch of like, I was stopping a turn early and I'm missing completely. There's a lot tighter turns on these arenas, it seems like. Now, if we come down to here, the other big thing that I did was I added a new const, and we have a break early modifier and a turn early modifier. And I'm using these for the speed changes, and for that's the modifier that changes the distance in which I'm going to turn off the engines, essentially, and then how many ticks I keep the engines off. So on the first map, I'm trying to be faster, and then on the second map, sort of like because I have like a little bit better understanding and I'm aiming for different part of the checkpoint, I found that this is a little bit better for us. And that's pretty much the big change that I did. Also, just sort of understanding that this is what needed to happen is another one. Oh yeah, and then also I'm only running this if it's the first map. So we're braking early on the first run through, the first lap, and then this is the second lap. So that was the big change. I think we should run this. I did not test this in the arena because I didn't want to, like, in the case that it accidentally coasts through all browns, I didn't want that to happen off stream. So we're going to test this in arena and see how it goes. Again, I wish I could do like partial full screen, like pull this out more, have this be a lot bigger. But let's see. So we're going to go until we lose at least one, which we're already in second place. So this is not. Oh, but they had trouble getting into the finish line there. So now we're ahead by quite a bit. So we're orange in this case. Here, I can turn off all this stuff to make it a little bit clearer. Oh, I can only do that from out here. I'm orange again. I'm in second place. This is not great. I don't know what that was with our opponent. He's staying at 2 for way too long, but we're about to lose this one. This one's really tight race. Oh no, that was a bad hit. Okay, I think we've reached the end. Oh right, it's not the last lap, but we're pretty far behind now. Okay, let's see where we ended up. We are now 44,432. Did we go backwards? I think we're at like 42,000 before, right? So not great. All right, so let's see what other things we can improve here. think you need to think about not only the next checkpoint, but the checkpoint after that, be in a position with no need to slow down after the first checkpoint. Yeah, that would be a good point. Like, how would I... Okay, so how would we program that? I know, so I have memorized, and I have in a vector a list of all the locations of the checkpoints. Now I'm trying to I'm trying to calculate exactly where to hit on the edge of them, so I don't have to go straight to the center. So if we're starting here, I know to turn early to get there. Okay, so U to U, like this one's pretty tough, right? Well, you know what it almost is like? If the checkpoint, it's almost like I want to calculate the angle between the next checkpoint and the checkpoint after that. And if the angle is big, go in it at full speed. And if the angle is small or negative, wait. I have that backwards. If the angle is small, go full speed. If the angle is big or even negative, like it's greater than 180, no, the angle can only be up to 180 on each side. So if the angle is like basically, if it's behind us, we want to slow way down. If the angle is small, you need to slow down. How is that? I'm trying to think like, okay, 0 to 1, and then, okay, so I'm heading to 1, let's say. 2 is like this, right? So, oh, I need to calculate the angle between me and this. So, right, I draw the triangle like that. And then I calculate this angle here. So I know it's a sharp turn. What is the math to calculate this? Here, this will be my pod. Here's the checkpoint I'm going after. Here's the next checkpoint here. So this is going to be checkpoint A. And then let's say that this is something like, so if we start, here's 0, 0, right? And let's say these are 10,000 by 10,000. So this is something like 8,000x and 8,000y to make it simple. And you're, let's say, halfway through. So your checkpoint B, you're like 5,000 by like 1,000. I don't really care. Do I really care about my position here? I do, because if I'm over here, that changes things. Can I do this? Will this work? No, I need sharp lines. Okay. So in this case, we need to turn a lot, right? Because I'm heading towards here at full blast, let's say. And then that's a pretty sharp turn. Also, you might want to hit the checkpoint on the right-hand side. Okay, so I need to hit... I wish I could, like... This thing doesn't sort of combine them together to have the angle be. Does it really? I guess that's going to be sharper. Than over here. Hello, Jim. How are you doing today? I do have a single boost that I can use. I have one boost that I can use in the entire match, and it's 3 laps across any number. So sometimes there can be 2 checkpoints and a finish line, and sometimes there can be 5 checkpoints and a finish line. It's sort of random which one we're going to get, and we don't know. Okay, oh wait. I added a tag in, backseat gaming allowed. So I am totally happy with backseat gaming. The way I figure it is that we're playing together, right? Like, to me, that makes it much more fun, is like we're all trying to figure this out together. Like, I don't want somebody to come in and actually just tell me this is how to do it. I want us to be like figuring out how it's going to work. And like solving a problem, like we're solving a puzzle together. Okay, so the angle for this, there's, man, is this, what type of math is this? Just geometry? I don't remember my geometry. I don't think I've done this in a long time. Let's see. I know that there's an angle. So I have a single vector here. So I would need 2 vectors. A vector pointing this direction and a vector pointing this direction, right? So to finish the triangle, it looks like this. So it's really going to be something like A, B, and C, right? Where it's like A squared plus B squared equals C squared. That's great. I can find the length of that by getting, like, you know, any of these distances. That's great. The angle, so let's go Google. Calculate. Well, first of all, is there something in Rust? I was thinking about getting x1 minus x2 and seeing if it's negative or positive. Let me see. So are you talking about just the x locations? So like the horizontal, like if this is to the left of this one. I guess like that's one way to think about it, is like, okay, is this on the same side as I am from this one? It's like I am on the left. Therefore, do I need to turn around once I get there again? If I figure out the angle, I could actually dynamically change my speed based upon this. Like if I'm down here, yeah, it's on my left, but I could come at this much faster than I could if I'm like over here. If point 2 is on the left or the right of point 1, yeah. So if you're not that one, if you're over here, that's obviously, I could just probably go full speed through that. I kind of do like the idea of finding the angle for something. What is it? It's yeah, my position matters a huge amount, right? Because if I'm over here, I just go full speed through it and I'm good. If I'm over here, I have to like go really slowly to turn around. It's dynamic programming all over again. I've never been good at like figuring out dynamic programming without trying to just memorize a solution. And I don't like doing memorized solutions, so I just get bored of it, so I stop. So like, to me, this type of thing is way more exciting because it's like, hey, we get to actually like solve real problems, even though the problem is it's not like actually I'm sending real coordinates to a real racer to do it, but hey, it's a game. It's fun. Okay, so calculate. It's really how to calculate angle of triangle. Let's go back to geometry class. Angle of triangle. So given three triangle sides, use the formulas transformed from the law of cosines. Ooh, cosines. Okay. So if we have A is, it's like inches, but this doesn't matter at all. So let's say A is 1 to, I can't literally just make this whatever I want. Why can't you just calculate that? It would be 1 squared plus 2 squared. 1 squared is still 1, right? 2 squared is 4. Here, let's just do, all right, let's start easy. 1, 1, 1. So that's 60 degrees. So if it's an equilateral triangle, it's 60 degrees. How do you calculate that? Okay, so given three triangle sides, which I have all three sides, like once I go through lap 1, I now know the position of every single checkpoint, including the finish line. So it's the length of each side squared. Oh, except minus a squared. And I'm getting the angle of this one. Oh, okay, I'm getting the angle of this one. So I'm going the two vectors of the one that I'm trying to get the angle of minus the vector. Okay, okay, so it's basically distance of vector plus the distance of vector, square those each, and then add them together. Subtract the square of the vector of the distance of the vector that's the opposite one. And then 2 of b times c. Okay, so I divide that 2 by t, and then I get a cosine. Okay, wait. So if the cosine times this angle equals that, it's the arc cosine of whatever this is. We could do that. You know what's great about programming is that I don't have to know what this, like what that actually is, because there are math libraries that are in the standard library for me. So all I have to do is add in rules. So if we have a function, calculate angle. We're going to take in 3 points, right? So we have the point, we have the angle that we're going after is going to be the one we have to know, like A, B, and C, right? So we have, what are that going to be? That's going to be calculate angle AB or something like that. And so if I have A point, B point, C point, this is going to be calculate the angle for the intersection, calculate the angle between A and B. Each input point is a do I want these to be a point? So the points in this specific case, these are really just distances, aren't they? Okay, so let's change this. Calculate angle to checkpoint. So we'll do distance to next, and that's going to be F32. And then we have the, I guess, like distance to target. And then we have distance, like distance, I want the target, like this is from target to the next one. So I'm trying to have like good names, but also like not be like in full sentences for each thing here. It's like my distance to target. Let's do this. My distance to target. We have next distance, or target distance to next. And then finally, we have the next distance to me. So if I have all of those things, I'm good to go. And then I'm going to get an F32, which is the angle. Okay, calculate the angle between my calculate the angle that will need to turn when we hit the next target, the next checkpoint. Okay, so we have those. Given this, we're going to calculate this entire thing. The angle doesn't give you a direction. No, it doesn't give me a direction, but I don't need a direction so to say. So the way the game works is that I give it an XY coordinate, and I just say I give it X, Y, and then power that I'm going to, and it basically just handles the movement for that. So I can say go to the top left corner 0 0, and even if I'm moving away from it, it will start turning towards that for me. So I don't actually need to worry about like how to make the turn at the velocity I'm going for, which is nice. But I can't, that this could help me determine, okay, we need to, when I'm like 500 pixels away or 700 pixels away from the from this upcoming target from alpha, I need to stop thrusting. Okay, so what are you going to be? We want... So really, it's probably going to be all one thing, right? So we're going to have that. Now we want b squared. So b squared is our distance to that. So my distance to target. What's squared? It's power. Okay, power to 2 plus c squared is next to the target. Okay, so that's target to distance next 2 minus next distance to me, how I 2. Okay, and then all of that over 2 times b times c. Now, this all has to happen first, right? So let's do let... What is this entire thing? I don't know what this is. Like, step 1. I do that first, and then I divide by 2 times b times t. So 2 times b is target distance to... Oh, b is mine. B is my distance to target times c is target distance to next. Interesting. Oh, you need to be dot 0. Okay. Calculate the angle. Then once I have that number, I get the arc cosine of it. And I think that I can just return that. So if I do step 1 dot arc cosine, return value is in radians in the range of 0 to pi, or not a number of the numbers outside the range. Okay. Okay, so this is going to be a number between -1 and 1, or not a number, if it's like not a valid triangle that we were working on. Okay. What's this? Inverse hyperbolic cosine. Okay, no, I'm not doing that. We're doing the arc cosine, and so I return that. Okay, so now calculate the angle to checkpoint. Hello, Diablo. How are you doing today? Weird that I'm streaming during Neo VimCon 2023. I wasn't even aware that's happening. What's Neo VimCon? Is it like, is there an actual convention for Neo Vim? I have never heard of it. I've never been a huge convention person though. So that would probably explain that. Is there anything interesting happening at NeoVimCon? Okay, so I want to calculate the angle, right? So I now need the distances between myself and the target. So that's, I guess we'll just do that here. So the distance, the distance between me and the target, so let distance, or like let our angle equals calculate angle to the next checkpoint. Okay, so my distance to target. We have our pod location. So this is going to be a pod dot position dot distance to, and then our current checkpoint, so that would be a target. So target, we'll just pass it in. And then you are target distance to next. To each, hello. How are you doing today? What is the angle we're trying to have? So I want to get the angle. So let's say I'm over here and I'm on my way into checkpoint 1 here. And then we're going to be coming up to next to the 2 one right here, right? So I want to get the angle, but then I'm going to have to turn. So the distance, so the target distance next, this would be the 1 to 2. So I have that as my target. That's going to be target dot distance to, and then the next one, checkpoint, get next, and then finally next distance to me, which is going to be the checkpoints, get next, distance to pod dot position. Okay. You want, can I do, no, okay, can I dereference you? I can't. Okay, perfect. Let's just print out the angle. Oh, but I can only do this if we're all mapped. So if we're all mapped, then calculate the next angle and then display it out. And that's it. We're not going to do anything with it. I'm going to use the angle as a modifier to figure out what the speed I should be going into the checkpoint is. Okay, so we won't get anything printed out the first time we're going through this. We'll see it after we get through the first lap. Okay, angle, not a number. Uh-oh. So for high angle, low speed, and low angle, high speed, I think so, yeah. Right, like if it's something like that where I don't have much to turn to get to it, we can go at a very high speed. But if it's like we need to turn all the way around again, that's not great. My angle is not a number, so I have not calculated the angle for this. So that's cool. So this did not work. If I convert degrees to radians. Convert radians to degrees. But that won't work for... I don't think that will work for this step one because you're already not a number. So if I say like 2 degrees, I don't think this changes anything. I think we're still not in a good state because we're getting not a number. Yeah, so from right away, our angle is not a number. Why can't you calculate during the first loop because you don't know all the checkpoint positions? Yeah, so the way this works is they only give me the target that I'm going after. So like they basically say, okay, here's the checkpoint that you're going after. That's it, like the XY coordinates of it. And so the first lap through, I'm storing those away until I receive the first one again. And then I'm like, oh, okay, I've seen all the checkpoints. Now I know where everything is. They don't let me know, like, you know, okay, checkpoint 1, checkpoint 2, checkpoint 3, checkpoint 4. They just sort of let me discover that. That's why I have to wait until after the first lap. Okay, so this is this wrong? Did I just do this completely wrong? Do I need to normalize these first? Hello, Gain. Hello. How are you doing today? You calculate the vector of the pod direction. Oh. Well, so what I did was I got the distance to it. So I just have the length to this one. But here, let's debug. You mean the blue arrow? No, that's their calculations. They're showing me the distance that I'm moving. It's just showing me the velocity. It's a relative. Okay, so hold on. All right, so I'm moving straight at it now. So it's basically the triangle is like this, right? So there. My distance to target, so this is 11,129.421. That seems appropriate. Distance, target distance to next, so between here is 5,615, and then distance to here is 6,248. That feels correct. Moomy, hello. How are you doing? So if I were to calculate this manually, so times, hold on. Let's do that squared plus that squared minus that squared equals, okay, and then I want to divide by 2 times that times that. That gives me, okay, that number, and then I want to take the arc cosine of that. Does this have an arc cosine? I see a cosine. I don't see an arc cosine. No. It's the arc. Where's the arc? It's the calculate the hyperbolic cosine of the displayed value. Are you sure that's what it is? Also, apparently I lost it. So that's cool. I have to do this again. Oh, wait, can't we just have, we can do, well, Wolfram Alpha can do this, can it? Is it alpha? It's been able to do this type of stuff for a long time. So I want to do, Natural language, because I don't know how to do the mathematical input type stuff. Okay, so calculate the angle for how do I do this? Calculate that calculator app sucks. Yeah, it's just like the operating system basic calculator, and like those are not really meant for much stuff. Calculate angle for this triangle. I have 3 sides. A is I have 3 sides with the following lengths. Just give the coordinates of the points. I guess I could do that. Yeah, I need to calculate that out. Hold on. Okay, so let's calculate out my point. So debug my pod is pod dot position my current target is target and then my next okay, so if I debug all those out, don't you miss the bracket around the divider in your code around the, did I? So a squared plus b squared minus c squared divided by, should that not matter? Because, oh, you're right. It's gonna matter a lot. Ooh. You're right, okay. That's probably a big, huge part of it. Okay, so I'll get those, and then also let's do this again. So we're gonna do let our angle equals. Okay, so my distance to target. That's gonna be my pod position dot distance to target. And then it's gonna be target to next. So target dot distance to points, get next. And then finally, checkpoints, get next, distance to pod dot position. Okay, so that has to go in there. Comma. Okay. Let's see that. To be honest, you also try to work with angles the first time you did the challenge, and you gave up the second time because it was too complicated. Oh, interesting. Okay. I wonder if we're gonna run into the same problem. Okay. We have my pod, current, angle. Ooh, we now have an angle. Okay. So this is exciting. We lost by quite a bit, but let's not worry about that. So hold on, lap 1. Okay. So we get through this. And now we have angle. Okay, so we're moving straight towards 1. So this angle feels like it's closer to 90 degrees, right? And if we look at that, yeah, angle, 90.28. Okay. So let's also, this is not great because every single one is a left turn, so it's always going to be to the left. Do I ever like overshoot it? No, because it's no matter what, it's always to the left. Okay, I want to do this again and find one where I have to be left, right, and then left, and then right. I want to see if it's negative and then positive. I bet it is. Is this always... This is again just another circle. Okay. Pomero, hello. ChatGPT. Okay, so... Well, just in case, let's do this. I don't actually care what the real angle is. I can just absolute value this, and then all I have to do is say, like, okay, I don't care about whether or not it's to the left or to the right at this point in time. What I do care about is, hey, how much to slow us down. So up here, let's not go after like the tuned angles. It's not even break early. Okay, so we're going to go after the original point regardless, like always the center. You don't think that 3 distances is enough to figure out the sign? I don't know if I care about the sign. I think I just care about if it's greater than 90 or less than 90. I think I'm going to start with that. So we're going to say const next sort of angle. What should I call this? Like, I want it to be the next angle, like the breakpoint. Like if it's below a certain amount, I want to slow down for it. And if it's above a certain amount, I want to like full speed ahead at it. It's like next angle something, breakpoint. Check. So we're going to start with 90.0. Next angle won't be enough, you think? Oh, yeah, and distance. Distance. We need if you are very far. Yeah. So I want const I have a break early modifier. If I change this to, if I don't do a modifier and I instead do something like break early. No, I probably do want to do this as a modifier. The most important is if you are well oriented. I guess. Oh, there's some other things we can do too, isn't there? Oh, I just realized. But so based on what you were saying made me realize there's a really cool thing we could do. So let's say I'm going from 1 to 2 here. If I'm past the if I'm before the halfway position and I know this line, I can position my I can tell my pod to aim out here. But still be moving at full speed. And then once I reach the halfway point, I aim back at the center of this. I probably oversteer to aim at the left, like to aim at the very top, like as close to this one, to just clip it as I'm coming in. So I'm really aiming like this, start steering back, just barely clip it. Then hopefully hit this. This one's gonna be a tough one. So like I need to hit, well, if I'm aiming like out here, turn back in, then hopefully it's not too tight to go after it. That would be really cool as a an aiming route. Then I can stay at full speed the entire route, the entire map. Except maybe the first lap through, because I don't know what where I'm going. And in that case, I don't actually need the angle, do I? What if I just invert this? I have the distance to you. I want with the same line, now you on the other side. Even for the first lap, you should consider the orientation. How do I know the orientation? Because I don't know where like position 3 is when I'm here on the first lap. I know my speed. I just don't know like how tight the turn is. So I can figure out the velocity, but I don't know how to use that. Like I don't know really what to do with that. if you point at a target and a pod turn directly, yeah, so the pod automatically turns for us. So I just basically say, okay, point at like, 10,000, X is 10,044, Y is 5995, 100 as speed. And then it just automatically does it. And even if I'm pointing the opposite direction, it'll then rotate and while it's moving forward. It don't turn to full angle in one turn. No, it might take several ticks before it finishes the angle. And I don't know the direction that I'm pointing. Like it won't tell me the angle that I'm pointing at. Yeah, absolutely. So here, let me get rid of some of these debugs. So here's my print line. And in the debug thing, I have my XY already positioned. Okay, so cool. This will work. We got rid of all of our... Nope. Okay, we got rid of all of our debugs. Okay, so here I am starting off with my position is 3,000. Here, I'll make this bigger. My position is 3536 X 6716 Y. Now it calculates the speed for the X and Y, which doesn't really make sense. I'm calculating my velocity of just a single scalar number based upon each tick, like the difference between each tick. I'm basically telling it to move towards this position, which is this very light tan line. That's where I'm aiming at. So I'm aiming at 9406x 7265 for the Y and 100. And so if we move forward, okay, so take a look at this. I collided with the opponent and it slid me a little bit left, but I'm still pointing here. So I'm not telling it rotate left, or sorry, in this case, rotate right. It's automatically doing it because I'm still telling it try to move towards that position. It hits there, and now my new target is here. Now I'm still moving, like I'm slowly turning like this. So my velocity is actually taking me this direction. But all I'm telling them is aim towards XY at 100 speed. I do not know how much angle it's going to be. It's going to be dependent, right? Like, look at this. It's still turning at this point, but it's a very small angle. But like, I don't know what that's going to be. And I don't get the choice of that. That's automatically created by the game itself. It does seem that the slower I'm going, is it the slower I'm going? No, it's hard to tell. The bigger angle that I'm asking it to go for, so like I'm saying, hey, go here, and I'm going this direction, it tries to turn a little bit more. Yeah, no, I mean, my target is just whatever I set it to be, right? So like I just like say, hey, go over here, go over here, go over here, and that's wherever it is. Like I get to set what the target is. In this case, like they give me the position of the next checkpoint. So every single tick, I get I get 6 things. I get the position of myself, so the XY of myself, the XY of my opponent, the XY of my of this. And that's it. That's all I get every single tick. And so as soon as I hit this, now it gives me the XY of me, the XY of my opponent, and the XY of this. And so now XY of this. And so the problem is on the first lap through, I have sort of, they don't give me my current speed, so I just calculate the speed based upon the difference between the previous tick, like my previous position, and my current position. That's all I can do. So my speed is a little bit off by 1, essentially, off by 1 tick, I think. But they don't give me that. I have to calculate that myself. And so I do that with a little bit of vector math. The video is at the end of the tick. Oh yeah, the video. So like each showing is after the tick has calculated. Okay, yeah. So basically, at this specific tick right now, whatever this is, because I don't think it tells me here. I think I have to look at. This is tick 88. I know what my velocity is. I have that in a variable. I would have to print that out in order for us to see it. This blue line is calculated by the game, and I don't actually get to. I get to see that sort of in here, but they don't make that available for me. If you print XY and you compare with the video, you don't have the same stuff. Like if I print, oh, because they give me, oh, okay. They give me different things. It's like if you're talking about like my XY, right? Do I want run or? Here, we'll debug my position. We'll do it in the exact same race that we have right here. Unfortunately, I can't zoom in on this. I'm going to have to look down here to see. I guess we could zoom in like that. This didn't really get that much bigger, did it? Oh, and I lost the controls for it. Cool. HD, okay, that's good. Okay, so here we have position 8282. You're right. How about the last tick? No. Oh, the next tick. Yeah, so there's an off by 1 error. Oh, right, because I always have I'm keeping in my positions the previous position that I have. And so this is my previous position, so I take 8919, and then I figure out from 8282, and then 6490 and 6594, and figure out my velocity from those two vectors. And that's how I calculate my speed. So I can basically calculate and say, okay, the faster I am, change the braking distance. But like, I'm wondering if that doesn't matter at all. I'm wondering if we just say, okay, if we're not halfway out yet, aim down like here when going to 2. So like here, I guess like the first lap through, I can't do that because I don't know that 2's on the left. I just know that 1's right there. But after the first lap, now I do know 1's right here and 2's right there. I could aim, instead of 1 right here, I can aim down here. What do you all think about that? So I turned that off. What is that thing? How do I do messages? I don't know how to do a message. Okay, so game plan. Can I just draw a pen? Is there a pencil? I don't think I have a pencil tool, do I? I want something like this. So if I'm going out there, I want to like click the drag straight lines, drag to draw curved lines. Okay. So I want to, oh, that's not, oh, I see. So I want to hit like here to come back around, hit here to come back around to hit this, to hit you, to hit like this again. It's like this would be like the ultimate, right? The ultimate pathing. This is really far out of the way. That would allow me to go at full speed though. Oh, I might have more data when I move up a league. Oh, interesting. So right now I don't have any more data. This is all I have. You don't think this is better? Yeah, that doesn't look, this looks like I'm going way more, like way farther. But I'm never slowing down. That could be good. At full speed, I think you can curve 15 degrees. Okay, so a 15-degree curve. I don't know what that looks like. Probably not like this. It's bad? Okay. And the max speed is still around 661. So then 15 is the threshold. Oh, okay. So if it's above 15, I need to slow down. And then the more it is, the more I slow down. Okay, so we're not going to do this. What we really want to do, not that. I want the pen tool. So we're going to start with this. We're going to go straight at you. No, that won't work. I need the curved. Oh, so I don't know that we're doing curved. So then, yeah, I guess that's it. Like I just need to slow down. You take a weighted average of the no slowdown path and a polygonal path where the weight varies based on the distance from the nearest checkpoint. A weighted average of the no slowdown path and the polygonal. What does that look like? Where the weight varies based upon the distance from the nearest checkpoint. I guess like I was thinking, okay, so this is over 15 degrees, right? So I want to slow down, and based upon my speed, I want to slow down like either here or here or here or not at all. So the biggest one is from 3 to here. That's a pretty big angle to go for at full, like close to full speed. So like here, maybe I start slowing down. Basically rounding the corners, but avoiding going too far in between checkpoints. Think it's better to move up. Yeah, so we're in Bronze League right now. So what I'm thinking of doing is just calculate the checkpoints and then calculate the angles and then slow down for it based upon like that. So the question is, what do I call these things? So our break early modifier, it's like, this is more of distance to break modifier. Remind me, Skimmas, hello. How are you doing today? Remind me again, what inputs are available and what can you output? So the inputs that I get are my position, the position of the next checkpoint, and my opponent's position. And the outputs that I can give are the X, Y of the current target that I'm going towards and my speed. Like, not speed, the percentage of accelerator that I'm pushing down. So like 100 through 1, like 0 through 100. You have it already, your orientation, your next checkpoint angle? Well, next checkpoint angle is just telling me the angle from my pod to the checkpoint that I'm going towards. What I want is to know what's going to be the angle between like this one. Yeah, I don't even have access to the orientation of the pod. I can figure it out. I have a velocity essentially. I don't think next checkpoint angle is what I want. Next checkpoint angle is between me and the angle that I'm going in the checkpoint that I'm going toward, not the one afterwards, right? So like if I'm heading towards 1 here, I want to slow down more for 2 than if I was like, if this was the next one, I can go for it at more like a bigger speed, higher speed. And the direction of the next checkpoint, it's the let's see. And the next checkpoint angle for the angle and degrees between your pod orientation and the direction of your next checkpoint. Is that really like the checkpoint after the next checkpoint? So I have my next checkpoint distance, so the distance between me and the next checkpoint. So is this really angle not between me and the next checkpoint right now, but the angle... Well, I don't directly have it. I have it in the form of this angle. All right. I haven't really played around with this too much. So we have this next checkpoint angle there. Let's debug that. Yeah, I'm not sure if that orientation helps me too much. Okay, so the angle is... So here, the next checkpoint angle is 0 right now. That's not helpful. I need to know that it's essentially 180. It's like behind me. And if I look at like here, I passed this and now my next checkpoint angle is 152. So it would have been better for me to know that I should be slowing down here before I reach this as opposed to after. And we have code in which we try to calculate and like start basically turn off our engines and start turning early, but we can't do that until the second lap through. So once I get to this position, now I know where everything is. I've reached the end of, I'm on lap 2. So I know coming into this one, you're at a sharp angle. So even though it says like I'm pretty much pointed directly at 1 with the next checkpoint angle, what I really need to know is that I'm almost completely reversed from 2. And so I need to slow way, way down to hit that. Then turn around and go, okay, well now it's a 90-degree turn. And so I can come at like half speed instead of almost no speed. Try this turn off engine if next checkpoint angle. But so the problem is next checkpoint angle isn't the next checkpoint between this and this. It's between me and this. It's more important. I could do that. So we could say we can just do, let's not do any view. We have our target that we're going towards. We do that, and then we'll just say if next checkpoint angle is greater than, let's next angle check, so what do we want to call this? Angle, so like slow down angle. So 90 degrees. Okay, so if that's if next checkpoint angle is greater than or equal to slow down angle, then pod dot skip ticks. We can skip like 1 turn, right? So skip 1. So we could try that. It has to be 90.0 because I have these as F32s. Oh, and I need, yeah, to be the absolute. You're right. I keep on doing that and forgetting that it might be -2. If you skip, you don't turn? What do you mean? Like I need engines on a little bit, you're saying? You need to keep the target but go at speed 0. That's exactly what this is. So skip ticks is really setting that, and then when I run, if my skips to tick are this, then I'm just setting speed to 0, unless I'm going too slow, in which case I clamp the speed so that there's a minimum. So it's not, I'm not actually skipping my turn. It's a lie. It's to me this works in my brain, which is I'm skipping like moving. That's all I'm really doing. Is I'm skipping like pressing the accelerator. I am still turning. I am still telling it a target to go at, because no matter what I do, we are still printing out where we're going. Just my pod gets speed when I'm skipping it. So I can skip, for example, I can skip 3 ticks. I can say, hey, I'm above like the slowdown angle. Let's like spend 3 ticks and make sure we're going at like, you know, to slow way down. So I could potentially break this up and say like, okay, if it's like above 15 degrees, slow down a little, like skip 1 tick. If it's above 90 degrees, skip like 3 ticks. So we can do 1 tick, and that way, as soon as we hit to the 90, it'll turn back on again. So the bare minimum slow down. So let's try this. So we're keeping it much, much simpler. Not sure whether or not you've heard of proportional navigation, but that's what you're solving here. I've never heard of proportional navigation. I've done some game dev before, but I've never really done, like, I've always brute forced it. I've never really like learned how optimally to do it. I've never done any like pathfinding or other stuff. So I do see the pod turning off its engines while it's trying to move rounds, which is good. Okay, so it's after 4:30, but today's Friday, and my wife's not home, so I'm actually not doing dinner with her today. I have a friend who's going to come over at 6, so I may be able to just stream later later than normal. It's control and guidance theory. Pretty simple to understand. Give it a read if interested. Interesting. Okay, let me add in a note. So what do you call this? This is proportional navigation. So look up proportional navigation. Okay, I will look that up. Now, I didn't win this one, but okay, so we're currently at 32. Let's just send this and see if that gets us better than 32. Am I crashing? I don't think I am. My speed is 100, except when I'm slowing down. So basically, I have, I believe I clamp it. So if I'm too slow, and my clamp takes effect, then I am, then my speed is set to 50. Otherwise, it's set to 100 or 0. So basically, it's either going to be 100, 0, or 50. This is a good race. I just always been slightly ahead of them. Uh-oh. Yes, that's where maybe if it's like more than 90, right? I should slow down a little bit more, or like potentially skip 2 ticks if it's above 90. The max is 100, yeah. So like I can imagine that 100 is just pressing down on the accelerator, like full blast. That's all I can do. And then over time that increases. Like I don't obviously get up to max speed in 1 tick, but if I hold down the accelerator for like 10 ticks, I'm a lot faster than I was after the first tick. So I think I'm doing better than my previous attempts. I thought we had tried this. Oh, you know what? We tried this in Wood League, and then that didn't work for something. Yeah, 90 might be too high. I think we should set it to like 80. I was gonna say like maybe like 75 or even 45 we could do. I wish we could do like a slowdown a little bit. Ooh, look, that boost was nice. What does that give us? All right, so it starts off at the very back of the league, and then slowly over time we'll get better. So we'll see what rank we end up. Yeah, not for the speed, then the 80 for the checkpoint angle. Yeah, so let's try that. So our slowdown angle, we can make that. Don't know why I don't like 80. I almost want to just do 75 because I like, because it's a, let's try it. Let's do the 80. 80. We're not using any of you, but that's okay. Wait. Oh, right. That's not what I was talking about. I was like, oh, at the boss already, but no, we're talking about last battles. Where did it get to? 44,000. Okay, so this is going to be an 80 instead of 90, and turn off the engine for 1 tick. So far looks good. Ooh, something happened. I got a notification of some kind. What happened? Oh. Okay, I'm still pretty far behind. I thought maybe like I ranked up or something, but no, that was somebody following me. I think it's the same sound when something like that happens. Okay, so I'm doing good. Let's test this in arena. So each time, I believe that this is how it works. I believe each time that I I need to change my my profile. That's from years ago. I haven't been an instructor with them for years. This one's not very good. I am not doing very good here. I think I needed to go either more than 1 tick, or I needed to change the angle again. I could slow down near a checkpoint, but I need to make sure that I slow down. Well, I guess like that, the question is like, on what side of the checkpoint do I slow down, and how do I know when to slow down, right? This one I'm going to do good at because they're all shallow turns. Wait, no, never mind. I was actually doing bad. I forgot. I didn't realize that I was pink. And I'm pink again. I am not doing very good. I do calculate my speed, so I can definitely use my velocity to make choices. And that's exactly what we were talking about at the beginning, like earlier on, is after the first lap, I can calculate the next angle. So not the angle that is to me and the next checkpoint, but the checkpoint and the checkpoint after that. And we did figure that out. So what we could do, so we have this angle to the next checkpoint. The speed you calculate is how much you move the last tick. Yes, is how much our velocity, yeah. So we have, if we're skipping the ticks, then we do this one. Why you care about the next checkpoint? So if I'm in the second lap or more, if it's going to be a sharp turn we're coming up to, it's like something like that, I want to go into it a lot slower. I want to slow down before I hit the checkpoint. And then that way I can turn down. So I can basically say, if the distance, if the next checkpoint distance is like less than something, like, you know, let's say 1000, and the angle is greater than, I don't know, like 80, then I want to skip a ticks, right? So odd dot skip ticks, like 1 or even 2. And then if we're not all mapped, I just want, no matter what, I want to like skip ticks if we're not pointed at our next checkpoint directly. What do you need to know if you can drift in and reach the checkpoint during a drift? I can do that, yeah. Well, and so like this one, it can be a good idea. We've tried that, and then I end up losing some because that can cause problems too. So with this one, the first lap through, I slow down, or I'm going 100, but now I should be slowing down based upon the how like close to it if it's a pretty tight turn. The problem is the turning time. If you're slow without turning, you waste ticks. Yeah, that's the other problem. Let's try this, because that went pretty well. Okay, we're pink this time. Ooh, I missed it. So did they. Okay. We're still... Oh, and that was very bad. So 2000 is, or 1000 is not very much. Sometimes I might be, my velocity might be close to 1000. I am orange or tan this time. Up. I need a higher degree than 80. Or I need to skip 2 ticks. I think 70 or maybe even 60. Let's do that. Are you always telling it to target the checkpoint? Yeah, right now I'm saying going to the center of each checkpoint. You know, I kind of wonder, let's try 60. Because I do have my minimum. And that should keep me going minimum wise. Another thing you're trying to do is go on the border of the checkpoint where I can reduce the angle. Yeah, so I have the calculations where I can actually calculate the border based upon my previous. Like, so if I'm up here, it goes to the bottom, the top right. So it just aims for here. But I might want to like aim around here and just go here instead. But I could also see a world in which I might want to aim for the other side and go around like this and try to hit the outsides of it. Yeah, this is not very good. I'm way too slow. Okay, let's go to what your suggestion was. 70. Oh, but I missed. That's the problem. Okay. So 65 or skip 2 ticks? If close speed at 50? Yeah, so like I want to be able to go at 100 into it if the angle is different, right? If the angle is small or big, I get those two reversed a lot. I want to go fast if the angle is big. So it's like really wide. So basically it's almost straight. And then I want to, so okay, this is where I would be. We have our two things. If our checkpoints are all mapped, where do I do pod run? I know I'm doing pod run somewhere. I do pod run at the beginning of each loop when I'm moving. Oh, I need to pod run in here too. That actually could be a problem too. And then if our checkpoints are all mapped and we're close to the target and above a certain, and the angle is do I want this to be opposite? Do I have this backwards? So I have my angle, and then my next checkpoint angle. You wish there's a way to choose an opponent in this? Oh, that would be amazing if we could do that. If we can like say, hey, can we just have a non-league battle with that? That would be awesome. Okay, so my angle is 0. Okay, so angle is 116. So if it's over 60, right? It's greater than or equal to 60. So I'm skipping a ticks. So it's not. My output is still 100. Because it's the next one. It's the next one. I think I want to run right before we do the print line. And then I also want to run if we're at this point. Okay, so hold on. What was that? I started off. Okay. Go at 100, 100. Why am I going slow? Oh, I'm not going slow. They use boost, which makes it look like I'm going slow in comparison. I just didn't use a boost. Everything's fine. Okay, so I hit this, and now, okay, now I'm at 0. So I'm turning. I'm still at 0 because it's over 76. Okay, I'm at 60, so now it's turning. Now it's at 100 again. Okay, so this is looking good so far. Okay, so I hit that. Now my next checkpoint angle. Okay, so now I can have the angle 71. So the 71 is going to be the angle between this. This is the 71 angle. Goku, hello. How are you doing? Do you control the direction of the racer? Kind of. I can tell it the target that I want it to go to, and it sort of does the thing. All right, so I didn't slow down for that, but maybe that's because it's 88, right? My slowdown angle, what did I put here? If it's greater than 80, I want it to... Maybe it's 2000? Okay, so we know that the first lap is kind of okay. Okay, what was that? So I'm coming into here and it knows that the next angle, so the angle between you and you, is 128. So actually I want that, because it's a big angle, I actually want to go more, right? So at this point, I cut off, because now it's at 155. Okay, so I actually want it to be less. I want to do the opposite. So I want to say, ooh, I need power. If you're less than or equal to, I don't know, like, so we can do something like second lap, second lap angle. I don't, so if it's 45. So if it's less than 45, let's say, so like it's a tighter turn that I have to make, then skip, like, I probably don't want to skip ticks, do I? I might want to skip a tick. Let's try skipping a tick for that one. Otherwise, if we're not even going close to it, like we need to slow that down, the angle, then skip the ticks there. Okay. Let's see if that makes the second lap going into 2 a little bit better. Okay, so I'm not slowing down too much. I slow down a lot there. But these numbers, the angle to it is all fairly large. So I'm not really slowing down too much, but that didn't really help. So basically on my second lap through, I'm staying at 100 for the most part through all of this. So here I should be slowing down. So the angle is like 70. So let's say if it's below 90, we can slow down. And I might want to do something like not have a, I guess like instead of a turn off the engines type thing, I might want to have a slow down instead. It's like either I'm turning off the engines, I'm going slow, or I'm going no, or I'm going fast. I feel like I'm closer. Okay, I slowed down a tiny bit, and that helped a lot. I got closer. What about you aim another point, then checkpoint itself? Yeah, I have that too. So like I could turn that back on again. So I figure out what the target is going to be up here. Let's not skip any turns. Let's just figure out what target I'm going after. What about you aim another point, then the checkpoint itself to take care of the inertia? I mean, for the next checkpoint? What do you mean? So like, let's say we're going after, we're like on our way to 1 here, and we know where 2 is. Does that mean we aim somewhere else, like around here? Forget 2. Okay. Are you talking about just aim here because it's the edge and that is just closer? Okay, so we don't care about the other ones. If you aim at 1 while having inertia, yeah. So I actually have a turn early thing that we did before. So this is like my turn early modifier. So if I figure out, yeah, so this would be getting the next. So this one tells me when I'm on my way to 2, start aiming at 2. And then let inertia take the rest of the way. Well, how do I know which direction to turn? Or are you just talking about like turn more, like turn double? So like if my angle is like, because my angle right now is 1, right? So are you saying like aim down here a little bit? So oversteering essentially? It's hard to explain. It's like there's a target which moves. Yeah, so that's the problem is like I need to understand in my mind what we're doing in order to like then figure out how I want to do it. Tea Kettle, hello. How are you doing today? So like I'm moving, I have an angle. So like I'm basically, my inertia is taking me this way, right? So I know that my angle here is 1. And then therefore I could oversteer. So I could basically say, pretend that the target is actually over here a little bit. So I have to turn, so it turns, it's trying to get here instead. And then every single tick, I could recalculate it back to here. How would I do that? So if I know the angle that I'm at, so if it's a negative angle, it's to the left of me. So I need to turn left more. But of course, I only know XY coordinates, so turn left doesn't really mean anything. If I'm moving to the left, turn left actually means go down more. Yeah, I have the coordinates in my previous position, so let's see. So remove it to my target. I don't know what you mean. Imagine a vector which goes for your current position to your previous one. Okay, so I already have that. Rickerston, hello. How are you doing today? Something like target equals the current minus the length. Wait, so then move this vector. I'm not sure what you mean move this vector on the target. Like what do you mean by move this vector on? Right. I get this is the real target, but I don't know what like the previous location. Well, so okay, I have the previous location, but if I really want like my speed, so the velocity as a vector. I could normalize that. Okay, so if I normalize the, yeah, I can do a drawing. So let's say let's see, what should I do? Let's say we're right here, and then our, not that one, I want that. So we know our velocity, right? So like we know that this is our velocity, let's say. So are you saying I can take this with that velocity exactly as is and aim the opposite direction? It's like aim down here. Oh, okay. That's what that is. And is that also the algorithm you gave Rickenstern? Is that what that will do too? My brain has trouble reading algorithms like that, so it like my eyes go fuzzy when I try to read it, unfortunately. I would have to like take it out and like put it in a visual format for me to actually like understand what's going on. Okay, so my thing targets 2 more, and more the closer you get to 1, for example, with some cutoff. Oh, okay, so it basically is a little bit more dynamic and a little bit fancier. We'll try the simple one to begin with, and then we can add fanciness in later. Okay, so to get this, so I have you to figure out this point here. If let's see, so I have this one. I don't want to reverse it. Do I want to reverse it? and then subtract. Let's draw it. So this equivalent is basically an angle like that, right? That's kind of what this is, with this angle being my velocity. Do people with degrees in control theory play this game? That would be hard to beat. That would be interesting to see. Maybe. Yes? Okay, cool. All right, so we have you. What, I can't drag you around? Oh, now I can. Do we care about the inertia of our body, the deceleration? Yes, we do. And that's where reconnaissance stuff probably comes in, is like, we don't want to cut off if we're going too slow. We want to change. We actually need to change this based upon our current speed, which is where the normalization comes in, right? Because I can take this and normalize it to a number between 0 and 1, and then multiply that by maybe our velocity to figure out how far we should start looking. I don't have a normalized function yet, so we can figure that out. But okay, so if I have the xy, so I have the xy of this. I just need to get the, do I need to get the distance? No. I just need to subtract the xy. So I need to take this position, subtract this, and that should tell me where to aim for. We could do a test where we reach some speed, set throttle 0, calculate the time to reach 0 velocity, and solve for the rate of deceleration. We could, yeah. We could also just play around with it and just tweak it until the numbers feel right. Real target, like the next checkpoint, plus the current position minus the previous position, and the same for y. And not just subtract the vector. Like, couldn't I just take this vector minus this vector? And then it gives me this. No, I need to normalize this. So I normalize this first, and then I can subtract the vector. You think the players at the very top use reinforcement learning to train their algorithms? That's what the game says you're supposed to be doing to eventually, like once you get to the higher ranks. So I would probably, that's what's happening. Okay, so it sounds like what I need is a normalization algorithm for this. And so on a point, I have distance 2, I have length, I have cardinal. I need normalize. Now, I forget how to normalize. It's I want to set it to be a number between 0 and 1, essentially. I do have the x and y. Like, I have the x and y of up here, essentially. Or really, I have the x and y. I guess the velocity, is the velocity a scalar? Where's my pod? I have a velocity as a scalar. So really, in my velocity, I just calculate my current position distance to the new position. So I don't keep that. So that's what I need to do, is I need to store my velocity as a vector instead of a scalar. So if I change this to be a point, calculate velocity is going to become self-dot velocity equals right, we have to do this if we're moving, otherwise we don't know what's going on. Self-dot, so it's really going to be self-dot position minus new position. Otherwise, this is going to be a point. Basically 0, 0. Let's see. Because in the end, you need to find an X and Y. To be honest, they ask you things. You don't need to move up in league. It's nice to like move up in league. If I don't move up, eventually I'll probably just stop playing and then move on to a different game. So it helps for that. Here, let's get rid of the normalize since we're not going to make that right away. Okay, so if I calculate velocity based on that, now I need to fix all the problems caused by this. So pod depth velocity, we'll get the distance. That's distance 2. I need... Oh, length. I need the length. Okay. You move to gold with only speed and next checkpoint angle. Interesting. Yeah, we tried to do that and I barely got out of wood, it felt like. So maybe I just got really unlucky. Or my attempts to do it were very not great. Jim, we need to write our own racing game similar to this in Bevy. Bevy is good, but I don't think it's ready for like full game stuff yet. But it would be fun to like make just something up with like a bunch of bots playing it. Okay, so if I have my velocity there with that, now that I have that, I want to calculate the next point. Nah, I don't want to I don't want to actually like just look at other people and how they do it, because that will influence me too much. I'd rather us just sort of like chat about things than sort of like then I can come up with it on my own. Because that's where all the fun is. The fun isn't actually winning. The fun is writing something and then watch it get to win. If that makes sense. Okay, so I now have my velocity in an XY, so like an actual vector. I can subtract the next. So I can, here's my target. So let's try this. Instead of doing all that fancy stuff here, instead of doing all the fancy stuff here, let's do a simple, we're just going to change the target based upon our velocity. And I just want to see that represented in there. So I want my let target equals, all right, so how's this going to work? I need to get my current velocity, which I have. So we have our pod dot velocity, and I want our next target location, the X and Y. So our next checkpoint, so we have that. So next checkpoint. So next checkpoint minus our current position. So Oh no, our pod dot velocity. And that's going to give me a point. So if I just try this, I'm curious. Your entire program has only 2 if statements and it's, oh, okay. Well, we could try rewriting our thing and then just try 2 if statements. I don't know why. I tried that when we first start. How can you fight against us? I really wish that we could. That would be amazing. That would actually be pretty amazing if I could say like, hey, I want my pod to fight against your pod, but I don't see anything on here that allows me to like challenge another bot. I think the main issue is they don't slow down enough for checkpoints. Yeah, we could try that. Oh, and I need to turn on debug mode so we can see. Yeah, okay, so our target is now changing. So that part is working. So now I want to change my speed based upon the angle. So let's see, where is that going to be? If this one, okay, so if the next checkpoint angle is greater than or equal to my slowdown angle, then just don't zero speed for like 1 tick or so. And then that is 60 or 70, I think, something like that. And then also based upon the distance more than the angle. Well, I need to do both, right? It's like if I'm greater than or equal to the slowdown angle. So let's do that one change at a time, right? So now I slow it down when the angle is too great. That's interesting. My aim is off. The calculations are weird. It's not going enough. Yeah, we're not. Do I need to add and not subtract? Am I using Rust? Yes, so this is Rust. What? Is add not a thing? Oh no, I just need to import it. Okay, so type output is gonna be a self. Okay, so I get our self on our right-hand side. So I want to do a self. We have our x is going to be self.x plus right-hand side.x. Y is going to be self.y plus right-hand side.y. Okay, so Yeah, it's one of my favorite things about Rust, that I could just start saying, hey, you're adding together. You now do that. Okay, I think I'm now steering correctly. Yeah, definitely much better. All right, let's shall we actually just see how this does in the arena? Let's see. Mine was around 10 lines of JavaScript code for Bronze League. Now I switched to Java and added a few stuff without any big differences, but you noticed on JS there's some kind of bug on the parameters you get. Oh, that sucks. Why am I always going after the center on this one? Oh, because I'm pink. That's why. I was like, I'm orange. Why is that working? Okay, so now I'm orange. So it does look like I'm able to keep higher speed than my opponents, and then make the turns a little bit better. So that's definitely good. So I'm able to take the inside track, which means that when we bump, I have a much higher chance of coming out on top. So this is good. Like that bump there. How do you get the coordinates? What logic? Let's see. So I am... it's pretty simple right now. I am... The first time through, I'm just... Well, actually, no matter what, it's like I'm mapping them up, but I'm just ignoring the map right now. So I'm just taking my current velocity. So that's the previous tick and the current tick. I'm subtracting those to get my velocity. And then I take that velocity and I add it to the target that I'm going for. And that is constantly changing its position. So that way I'm always aiming for the target, but keeping my current velocity in mind. So I'm turning faster than my opponents, unless my opponent does the same thing. This is looking pretty good though. Like I'm not even using boost on most of these because I don't think I ever have like a direct point that's long enough that my whatever it's called, my pod is like comfortable with boosting. But it doesn't matter. A lot of stuff to do before thinking 2 checkpoint after. Oh, come on. It's fun to think 2 checkpoint after, right? I have to overcomplicate things. I'm surprised. I wonder if I boosted off screen, because that felt like one I would boost at. Ooh, I'm in second place now. Okay, back to first. This one's pretty close. That bump. That bump at the very end. That's what made me win that lap, that race. I am pink this time. Oh, that one was really good. Ooh. That was a bad bump for me. All right, we're orange this time. Oh, this is like unfair in my advantage. I'm pretty good at, my bot is now very good at turning these tighter turns. Ooh, I'm fighting the boss, so I'm pink. All right, if I beat the boss, we'll get out of Bronze League. I think I need to do that offset target by speed trick too. It seems to make a bit different. It's made a huge difference. Thank you to each. This was great. It did take me a while to understand it, but then once we got it, we got it. I'm beating the boss by a mile. Wait, yeah, no, I am. I keep on thinking I'm the tan, but no, I'm pink. There we go. So now it'll have me fight against others trying to get above the boss, but I think this means that I'll be promoted soon. Rank 1. I think this will tell me soon. It usually has like a slight delay on it. Maybe I need a refresh. Also, am I missing? Isn't there normally like notifications up here, or did they? Oh, they moved it over here. Okay. I don't know how long I have to sit here and wait until we move up to the next rank. Oh, the promo check is done periodically. Okay, okay. So basically, we're waiting here for a while. Well, cool. So I don't actually know what the next challenge is because every time you level up and go to another league, they add another like thing for you to do, and it might take a little bit of time before we get to that point. How do you know that it's happening in 35 minutes? Is that listed somewhere? Click the leaderboard tab. Detailed leaderboard. Oh, this one. Oh, oh yeah, I see. 6:13 p.m. Okay, cool. So nice. Okay, cool. Then there's not much for us to do until Monday, because I don't want to tweak the code until we get to the next thing now. I'm doing way better than you now. Okay, nice. Not to discourage. Oh, I'm in sec. I'm not winning this battle though. This one's really close. You're in the running. Look at the leaderboard. Okay. Can I make this 4 and turn faster than M? No. Oh, I came so close. All right. Jim FYYC. Let's see. Leaderboard. Jim F. Oh, I see. Okay. Wait, can I watch your battles? No, that's not what I wanted to do. Oh, that's too bad. Last battles? Can I watch? Oh. That's really too bad. You can add it on your match. How do you do that? And wait, so you can battle against other people? Wait, how do you do that? Yeah, I saw you're using JavaScript, but it doesn't matter. Language remove boss. Oh, it's here. Oh, this is okay. All right, well, let's do this. I had no idea we could do that. Jim. Let's see. I don't find it. Oh, maybe. Let's see. Leaderboard. Okay, so I'm following you. Gamers you follow. Doesn't help. Do I have to refresh after doing that? Okay, yes, thank you. I don't see it. Jim Star, you think? No? Who are these people? Are you in here, Jim? And I just not finding it? No, not that. I want to find... Oh, I can't do Command F in here. It's not letting me search with like the normal... Oh, there we go. Oh, that's the only Jim that I could find. Jim... Yeah. Is it infinite scroll? Wait, but you're like 40... Oh, look at this. I can only go down to... Okay, so you have to be within 1,000 of me. I think that's what it is. So we have to be in the same league, and so I'm at position 1, so you have to be at 999 or less. Oh, that's too bad. That kind of sucks. Because otherwise we'd be able to Just go straight for it. Oh, and this is cool. I have the Codin ID and Codin Arena, so I can fight against myself. And then I like this a lot more than just going for the boss, right? Like if I play against myself, now this is literally the same code, then I can just see, am I better than I was before? That's all I really care about anyways. Moomy, you could find me even though you're... Okay, maybe I can find you, Moomy. What's your username? Huh, I can't find you. I must only... Oh, maybe I can only go against the 999 behind me. Or... Wait a second. Frext is number 2. Is that Silver League? No, this is Bronze League. Frex is... Okay, Frex is number 2 in Bronze League. Okay, never mind. So yeah, I'm only allowed to myself race against behind me 999. Maybe. What's the lowest? What's the... Do you have the same list of people that you can fight against? You can race against? Like for me, if I like just keep on paging down and go to the bottom, this is the bottom. It stops loading after this. Are these the same people that you all have? Oh, okay. So you're only allowed to compare yourselves to the top 1,000. Okay. So interesting. That kind of sucks. So we can... It'd be funny if I could figure out, oh, look, I'm fighting against the boss. And so then I just die on the boss. I just never go to the never go to the actual, like, you know, next checkpoint. We just need to get good. Yeah, clearly. Is there a feature request? I don't see a like easy like feature request or something else in here. So that's too bad. Ooh, hold on. All right, the friend I mentioned is outside right now, so I need to go hang out with him. So we're going to do an emergency stream shutdown, but we got to first place. So awesome. Thank you to each for the help with that. And then everybody else, thank you for hanging out so much with me for this journey. We're getting out of bronze and we're going up to silver. So we'll be back for more Mad Pod racing in Silver League on Monday at 2:30 p.m. Mountain Time. And then on mornings, so Monday morning at 7 a.m. Mountain Time, we'll be working on a U application in Rust. So with that, have a great rest of your day, have a great weekend, and see you next time. Bye.